Bismillah ar-Rahman ar-Rahim. My name is Ali Al-Jizani and this is EE419. Our subject is Massive MIMO for 5G and beyond. On behalf of Dr. Ali Mgabel and my colleagues, the presenters who are Ali, myself, and Ahmed Ramadan and Haidar Al-Najjar. First, let's start by stating the objectives. What is MIMO? And what is the advantage of the MIMO? And why do we need 5G? And MIMO and 5G, challenges of using MIMO, future of massive MIMO 5G system, comparison of microwave and millimeter wave massive MIMO 5G communication systems. First, let's define or talk about what is MIMO. MIMO stands for multiple input, multiple output. It's a wireless technology that uses multiple transmitters and receivers to transfer more data at the same time. All wireless products with 802.11, and this is the, by the way, this is the, let's call the code or the terminology used in IEEE, support MIMO. The technology helps allow 802.11n to reach higher speeds than products without this code. Okay, what is the advantage of the MIMO? The advantage of MIMO is the higher capacity, as you can see in this, without requiring more spectrum. This is very important. The spectrum is very, very, very expensive. Okay, why do we need 5G? 5G, has high capacity, and as you can see in this graph, it summarizes the need for 5G, and also this figure, as you can see, 99.999 availability, 100 coverage, and other capabilities of using 5G. This slide, the MIMO and 5G, will talk, my colleague will talk about it, who is Ahmed Ramadan. You can start, Ahmed Ramadan, now.
Ali, hello everyone. Today I'm going to be presenting two parts of our research, which are MIMO and 5G and challenges of using MIMO. MIMO and 5G. 5G is the fifth generation of mobile networks that was capable to convey the high demand of the networks from the social and industrial medias. The 4G transfers data in the speed of 20 gigabytes per second. On the other hand, 5G in more than 100. The increase of the data rate required a topology to help transferring such high rates. According to John Mundy, Cisco estimated that in 2020 there will be 5.5 billion mobile users globally consuming 20 gigabytes for each person in 1 month. Based on what has been presented, experts found that supplying this high rate of data requires the use of multiple input, multiple output, where Vodafone and Nokia teamed up to make the first trials of this topology in 2018. Furthermore, in 2020, a number of companies officially use MIMO, such as Apple, Samsung, and Huawei. Challenges of using MIMO. The engineering is like a scale where a change in one side shall cause a change on the other side. Therefore, there are some challenges implementing massive MIMO. Firstly, MIMO operates on millimeter wave frequency, resulting in a small wavelength 1 to 10 millimeter. Due to the small wavelength of MIMO, we need hundreds of antenna elements while only few are available. Another obstacle that can be faced while implementing MIMO is power. MIMO operates on TDD, stands for time division duplex, rather than FDD, frequency division duplex, which means that we transmit data for the whole bandwidth but for half of the time. This makes the TDD SNR signal to noise ratio 3 dB lower than FDD. There is always some unfortunate low SNR users who would like to communicate at maximum peak power in both uplink and downlink. Therefore, they suffer from this 3 dB SNR loss. From now on, Haidar Al-Najjar will carry on.
Thank you, Ahmed. My name is Haidar Al-Najjar, and now I will talk about future of massive MIMO 5G system. Currently, cellular networks use microwave frequencies with massive MIMO system, and also called conventional massive MIMO. However, they are expected to undergo from microwave to millimeter wave frequency bands because of several causes, such as explosive growth in mobile traffic, the proliferation of increasingly smart applications. These networks are required to deliver high data rates, super speed connectivity, support diverse use cases, provide better coverage. Millimeter wave massive MIMO 5G communication system can afford the foreseen requirements, such as higher capacity, delivering super speed connectivity, much higher data rates compared to microwave frequency band. However, as you can see from this table, it has several disadvantages compared to microwave frequency band system, such as lower gain, higher path loss, larger shadowing, required more handoff because of blockage. Therefore, it is planning to use, go to next slide. It is planning to use a new design called multi-tier HitNet. It's composed. This design is composed of the micro cell and small cell base station. Small cell base station for millimeter wave communication capability. For example, small cells where closed by user are served by millimeter wave access links, while further away users are served at microwave frequency band. In conclusion, we have discussed why is massive MIMO important for fifth generation of wireless communications, its challenges, and one expected future design. And this is the end of our presentation. Thank you.